when we dissolve salt into water, what is our expectation is that all the ions should be getting dissolved, right? If you take a NaCl salt, what you have expected in that, what you have seen into that, right? NaCl, if you take sodium chloride and if you put this into water, then it gets dissolved in water. You get Na plus aqueous and the Cl minus aqueous ion, means all the there is complete dissociation of the NaCl, and the NaCl is getting dissolved into a water. Maximum of the NaCl, like almost everything will get dissolved into a water. So this is one type of salt, like ionic salt. Like this is a salt in which it is getting completely dissolved. There are many examples like a KCl. If you take a KCl, then this will get completely dissolved in water, right? What I will say that it is highly soluble in water, water soluble KCl. Then you can take more examples like a silver nitrate, AgNO3. This, if you dissolve in water, it is going to get completely dissolved. There are some salts like there are some salts which are like AgCl, okay, then a barium sulfate, or PbCl2, then AgBr, zinc sulfide. These are the compounds, these are the salts which are sparingly soluble, means very less amount. If you take one like 5 gram, then very less amount, 0.1 gram will be going into the solution, 0.001 gram of that compound will be going into the solution, remaining weight will remain as it is, right? These are the salts which are sparingly soluble. Sparingly soluble means these are some of the examples of the salt which are sparingly soluble. Hardly anything will go into the solution. Means, let's take an example of AgBr. Let's take the salt AB. I am taking a AB is a salt which is getting dissolved sparingly. Sparingly means there will be some equilibrium. Always there will be some equilibrium if it is a sparingly soluble. A plus and the B minus aqueous, and this is B minus. This is sparingly soluble. A very less amount of it is getting dissociated into the aqueous solution, right? So here what happens is that, like if I put this into a water, I mean, right? So AB is there. So here this is the AB, and it is getting dissociated. It is getting dissociated into water. So if you want to write the equilibrium constant, so you will write the concentration of the A plus, concentration of the B minus, that is product, upon the reactant is concentration of the AB. The concentration of the water is going to still remain constant, because very little amount of that sparingly soluble salt is going to go into that liquid. So it is going to remain constant, and this concentration of the AB which is there, AB is a very solid salt and hardly anything is going into the solution. So this together will be called as, like if I write this over here, okay, let's not consider this water, right? I'll not write this over here. Let's not write this over here. Okay, it is concentration of, anyway water is going to remain constant. That's why I am writing this way, AB in the water, A plus and the B minus. This is the new constant which is formed, because this is also a constant and this is also another constant. This is called as KSP. KSP means a solubility product, which is equal to concentration of A plus and the B minus. This is what the definition of the solubility product means. This solubility product tells about the how much of the salt is getting dissociated. Okay, now let us understand what is solubility over here. So here, let us understand the relationship between the solubility, like solubility will be given by this symbol S. Relationship between the solubility and the solubility product S. Like I will take one sparingly soluble salt of the type AB. AB means what it will include is AgCl or AgBr or lead sulfate. How to write, what is the relationship between the solubility and the solubility product? Over here, let's take a AgCl salt, or I will just write 1:1, it is AB. So let's take this AgCl. So this is going to split as Ag plus and the Cl minus, right? So for this KSP, okay, KSP will be is equal to, this is S, like concentration of Ag plus and the concentration of Cl minus. Now how this is related to the solubility is, I can say that this is S of this and multiplied by S. So this is KSP is equal to S square. Therefore, S is equal to KSP raised to half. This is of the, when it is AB type. When type 2, that is AB2 type, okay, means over here the solution, the compounds will be like PbCl2 or yeah, we can take this example PbCl2. Like here the KSP, the solubility product, we will be writing to be like PbCl2 is there, then this is going to split as like sparingly soluble, no? So I should show this type of arrows. So this is Pb2 plus and 2Cl minus. So I am getting one ion of this and I am getting two ions of this. So I am writing the solubility product is Ag2 plus raised to 1 it is, and it is concentration of Cl minus raised to 2. So since there is one ion of lead and another ion of two ions of chlorine is formed, I will be writing solubility S raised to 1, and since this is from two ions, so I will write 2s raised to 2, right? So KSP over here, I can write this to be S multiplied by 4 multiplied by S square. So this is 4s raised to 3, this is KSP. So over here, S will be related as KSP divided by 4 raised to 1 by 3. This is how the KSP will be related for solubility, and the KSP will be related for this type of salts. Next type is of the AB3 type. AB3 type means example is AlCl3. We can take this example. If AlCl3 is there, then it will form an equilibrium this way. Al3 plus and 3 ions of Cl minus. This is how the equilibrium will be established between this. So KSP for this is equal to concentration of Al3 plus into concentration of Cl minus raised to 3. Since there is one ion of silver, I will write this to be S raised to, solubility shown this way, S raised to 1, and there are three ions of chlorine. So the 3s raised to power 3. So this is s, and this is 3 raised to 3 is 27, and this is s raised to 3. So this is 27 s raised to 4, that is Ksp. So for this s will be, solubility will be 1 upon Ksp upon 27 raised to 1 by 4. It will be this, right? So s raised to 4 will be Ksp upon 27, and s will be is equal to 1 by 4. So next is of this type. Let's understand. Next is of AB2 A3 type. A2 B3 type. A2 B3 types. If any salt is there of this type, A2 B3 type, it will dissociate as 2A plus and 3B2 plus. It will dissociate this way. 3 ions of this with -2 charge, and charge is balanced, right? So here Ksp will be is equal to concentration of A3 plus raised to 2 and concentration of B2 minus raised to 3. So here how many ions of A is forming? There are 2 ions of A is forming, right? So it will be 2s raised to 2, and this is 3s raised to 1 minute, raised to 3. So this will be 4 s raised to 2, and this will be 27 s raised to 3, right? 27 into 4, how much it comes to? 27 into 4, 108, right? So this is 108 s raised to 5. This is equal to Ksp. So s is equal to Ksp divided by 108 raised to 1 by 5. 1 by 5. So Ksp for the different types of salt, okay, for the different types of salt, like any type of salts, any sparingly soluble salt is derived experimentally, and they have some fixed values. For this particular salt, it will have a particular value of its solubility product. You don't have to study those. It will be provided for you in the exam. That's the only thing. So solubility product is a constant thing for one particular type of salt.